The configuration of the double bond in the molecule below is best described as. So this question is asking us about the stereochemistry of the alkene. And so the stereochemistry of the alkene can be described by E or Z, and these terms will work for all alkenes that have stereochemistry, or cis or trans. So cis and trans are very specific terms when it comes to alkenes. So a cis alkene would have two hydrogens. So you have to have two hydrogens to compare on the same face of an alkene. So you have to have a hydrogen on each carbon atom of the alkene. And the same idea for trans, you do have to have a hydrogen on both carbon atoms of the alkene, but they're going to be on opposite sides, like this, for the trans isomer. So to use cis or trans, we'd have to have hydrogens on both of these two alkene carbons. So I'm going to highlight one alkene carbon in this pink, red color, and the other in this blue color. And so we can see that the carbon that we've highlighted in pink, we have 1, 2, 3, 4 bonds that we're already seeing. So there's actually no hydrogen atoms attached to that one. There is a hydrogen on the blue carbon atom, and it would be right here. And we know exactly where to place that by remembering that the alkene carbon is sp2 hybridized, which means we're going to have trigonal planar geometry. So because we do not have a hydrogen on each of the alkene carbon atoms, we cannot consider this to be either cis or trans. So we're going to need to use E and Z. So the E isomer would have the high priority groups of the alkene on opposite sides, and the Z isomer would have the high priority groups on the same side. And so to determine if it's E or Z, we need to take a look at this alkene and assign the priorities. So we assign the priorities to the carbons of the groups on that alkene carbon by atomic number, and we go atom by atom until we find a difference. So if we look at this pink carbon atom, we're comparing this chlorine to this carbon. Chlorine has the higher atomic number, so that is going to be the priority number 1, whereas this group down here is going to be the priority number 2. If we consider the blue carbon of the alkene, we're comparing a hydrogen to a carbon. Carbon has a higher atomic number than hydrogen. Actually, everything has a higher atomic number than hydrogen, which is number 1. So that means your highest priority group here is on the top, and the lowest priority group here is the hydrogen on the bottom. And so the important thing now that we've got these priorities assigned is to know how we're bisecting this alkene. How are we saying the same side or opposite sides? So you're always cutting straight through the center of that alkene to compare. And we can see that the number 1s are on the same side. And that is matching this Z stereochemistry. So this is a Z alkene.